If you've ever chopped an onion, you know exactly what happens next. The stinging, the watering, the full-on tears. We've all just accepted it as part of cooking. But what if I told you that it's not just some random irritation? It's a calculated, high-speed chemical assault. Let's get into the incredible science of why onions make you cry.
Yeah, you heard that right. We're not talking about some passive gas that just kind of floats up to your eyes. No. The latest science shows that the humble onion has perfected an incredibly aggressive defense mechanism over millions of years of evolution. And trust me, the real story is way more dramatic than you could ever imagine. So, to really get this, you need to stop thinking of the onion as a vegetable and start thinking of it as a tiny, brilliant chemical weapons factory. It actually builds what's called a binary weapon. That means it keeps two totally harmless components separate, and they only become dangerous when they're mixed together. It's an unbelievably clever strategy. Okay, so the first ingredient in this weapon comes right from the ground. Onions are amazing at sucking up sulfur from the soil. Then they convert that sulfur into a specific molecule called isoallium. This is part one of our binary weapon. On its own, it's completely harmless, just sitting inside the onion cells, waited. You know, this right here answers that age-old kitchen question, why do onions make you cry but garlic doesn't? Well, look at this. It comes down to a tiny little difference in their starting chemicals. Onions use isoallium to make their tear gas. Garlic, on the other hand, uses a slightly different precursor, allium, to make something called allicin, which is a great antimicrobial, but thankfully for us, it doesn't target our eyes. A tiny chemical tweak with a huge difference. Right, so inside the onion cells, you've got the precursor, isoallium, just floating around in the main part of the cell. But the trigger, this enzyme called alliinase, is locked away safely in a completely different compartment. So as long as those cell walls are intact, the two can never ever meet. The weapon stays unarmed, the onion is perfectly safe to itself. But the very instant your knife slices through that onion, everything changes. The cell walls burst open, and those two harmless components get mixed together violently. This kicks off a lightning-fast two-step chemical reaction that launches the onion's weapon. So let's break down exactly how it happens. First, that trigger enzyme, alliinase, immediately gets to work on the isoallium, creating this really unstable acid. Now, for ages, scientists just thought this acid randomly broke down and turned into tear gas on its own. But here's the key, step 2. There's another specialized enzyme called lacrimatory factor synthase, or LFS for short. This enzyme literally grabs that unstable acid and, in an instant, converts it into the final product, the tear gas itself. And this is so cool because the discovery of that LFS enzyme back in 2002 was a total game changer. It proved that making you cry is not an accident. It's a deliberate, enzyme-driven biological process. The onion has evolved a specific tool with one job and one job only, to make this powerful irritant. But believe it or not, the chemical is only half the story. Because the way the onion delivers this chemical, this is where the story gets really wild. For decades, we thought we knew the whole story. But a brand new discovery revealed a delivery system that is so much more aggressive than anyone ever dreamed of. The old model was, pretty straightforward. You cut the onion, a gas is made, and it just kind of slowly drifts up into your face. Makes sense, right? Well, it turns out it was completely wrong. The onion is not just sitting there waiting for you to lean in and take a whiff. Get this. Researchers at Cornell University just discovered that when your knife crushes and ruptures the pressurized cells inside an onion, it doesn't just release a gas. It forcefully ejects a high-pressure aerosol spray of microscopic droplets at speeds up to 40 meters per second. That is almost 90 miles an hour. I mean, to put that in perspective, just look at this chart. When you cough, you're propelling droplets at about 20 meters per second. The onion's chemical spray can be twice as fast. It's an instantaneous, targeted blast of irritant aimed directly at the face of whatever is attacking it, which, in this case, is you. So this high-speed chemical missile hits your eye. What happens then? How does your body even react to this tiny assault? And why does it trigger such an immediate, watery defense? All right, first, we need to bust another big myth. You've probably heard this one. The onion gas mixes with the water in your eyes and forms sulfuric acid, and that's what stings. And while, some acidic stuff might form, that is not what's causing that intense burning pain. The real mechanism is way more direct. Your cornea, the surface of your eye, is covered in these super-sensitive nerve endings. And on those nerve endings is a special protein called the TRPA1 receptor. The easiest way to think about this is as your body's chemical fire alarm. It's specifically designed to go off when it detects harmful reactive chemicals, the same stuff you find in wasabi, mustard oil, and, you guessed it, onions.
So here's the bottom line. That tear gas molecule from the onion is perfectly designed to directly attack and trigger this TRPA1 fire alarm. The receptor immediately sends a pain signal screaming up to your brain that says, "Threat detected, we're under attack." And your brain responds instantly by telling your tear glands to open the floodgates. Those tears are a reflex, all in a desperate attempt to wash the chemical weapon away.
Okay, so now that we understand the onion's sneaky biochemistry and its frankly shocking high-velocity physics, we can finally talk about how to fight back. How can you use this science to actually win the war in your kitchen and chop an onion without crying?
All right, these are the hacks that are actually backed by science, and here's why they work. Chilling the onion for about 30 minutes literally slows down those enzymes. Using a really sharp knife gives you clean slices instead of crushing the cells, which seriously cuts down on that 90-mile-an-hour aerosol spray. Good ventilation, like a fan or an open window, just blows the irritant away from your face. Goggles? Well, that's a simple physical barrier. And finally, cut the root end last. It has the highest concentration of enzymes, so you want to minimize your exposure time.
And all those old folk remedies, yeah, don't bother. Seriously, holding bread in your mouth or chewing gum does absolutely nothing to stop a high-speed chemical spray from hitting your eyes. A single candle flame can't possibly burn off all that gas. And biting a metal spoon, that has zero pieces in science. They are all just total distractions. But what if you didn't have to use any hacks at all? What if we could just permanently disarm the onion? Well, thanks to our new understanding of its genetics, the future of tear-free chopping is actually already here.
There are basically two ways to do it. On the high-tech side, scientists can use genetic modification to simply turn off the LFS gene, the one that makes the tear gas enzyme. And what's cool is this actually pushes the sulfur into creating more healthy, flavorful compounds instead. Or you can go the old-school route. Brands like Sunyons have used decades of careful, natural crossbreeding to create onions where those irritating compounds just naturally disappear over time while they're in storage. So the next time you slice into an onion and your eyes start to water, try to remember what you're really up against. Those tears aren't because of a flaw in the vegetable, they're a sign of its incredible strength. It's a testament to a perfectly evolved, high-speed, microscopic defense system. An evolutionary masterpiece of chemical warfare hiding in plain sight, right there in your kitchen.